Hello everyone. So let's now solve practice assignment week 5 question number 2. A molecule is composed of atoms. A molecule of ethylene with the chemical formula C2H4 consists of 2 carbon atoms C2 and 4 hydrogen atom H4. A molecule of oxygen with the formula O2 consists of 2 oxygen atoms. Note that the carbon, hydrogen and oxygen are denoted by the letter capital C, capital H and capital O respectively in the formula. When ethylene comes in contact with the oxygen O2, carbon dioxide CO2 and water H2O are produced as the products of the chemical reaction. The equation corresponding to the chemical reaction R is given below. C2H4 plus O2 equal to CO2 plus H2O. To balance the chemical equation, we have to choose x1, x2, x3 and x4 such that both sides have the same number of carbon atoms, same number of hydrogen atom and same number of oxygen atom. That is, the number of carbon atom here should be same as the number of carbon atom on the RHS side. The number of hydrogen atom on the LHS side should also equal to the number of hydrogen atom on the RHS side, and same for oxygen. An example to write the system of linear equation for balancing the chemical equation is the following. So here we have x1 number of carbon atom on the LHS side and x3 number of carbon atom on the RHS side. So our system of a linear equation would be, first equation is x1 equal to x3, and for oxygen we have x2 number of oxygen atom on the LHS side and 2 times x3 number of oxygen atom on the RHS side. So x2 should be equal to 2x3, and that's how we get our system of linear equation from a chemical reaction. Now consider the system of linear equation obtained for balancing the chemical equation R to answer the question. So we have given the equation x1 C2H4 plus x2 O2 x3 CO2 plus x4 H2O, and this is our equation R. Now we have, so let's first check for carbon atoms. So carbon atoms, that is C. So we have 2x1 carbon atom on the LHS side and x3 number of carbon atom on the RHS side. So our first equation would be 2x1 is equal to x3. Similarly, we have 4x1 number of hydrogen atom on the LHS side and 2x4 number of hydrogen atom on the right hand side. For second equation, that is for hydrogen atoms, H would be 4x1 equal to 2x4. Now our third equation would be for oxygen atom. So we have 2x2 number of oxygen atom on the LHS side and 2x3 number of oxygen atom plus x4 number of oxygen atom on the RHS side. So our equation for oxygen atom would be 2x2 from the LHS, that is equal to 2x3 plus x4. Now if we try and simplify this equation, so we will get 2x1 minus x3 equal to 0 from first equation, and 2x1 minus x4 equal to 0 from second equation, and similarly 2x2 minus 2x3 minus x4 equal to 0 from the third equation. So now we have our system of linear equation. So if we try forming the matrix for this system of linear equation, Ax equal to b, we will get 2, 0, minus 1, 0, 2, 0, 0, minus 1, 0, 2, minus 2, minus 1. So this is our A matrix. Our X matrix is nothing but this, and that is equal to 0, 0, 0. So now we have found our matrix representation for the system of linear equation. So if we want to solve the system of linear equation, we have to find the augmented matrix. So as our B matrix is 0 row, so we can even remove it for our row reduction process. So now if we reduce this matrix in its RREF form, then we will get 0, 0, 1, and minus 1. So this will be our row reduced matrix for the matrix A. Now let's read the question. Which of the following options are true? So the first two options are talking about the nullity of the matrix. So this is the reduced to echelon form for the matrix A, and as you can see, it has three pivot elements. So the rank of the matrix would be 3, and that's one independent variable, as it is a 3 cross 4 matrix, so rank is 3, so the nullity would be 1, and also we have one independent variable. So from that also we can say that nullity of the matrix would be 1. So option 2 is correct, as it says nullity would be 1, while option 1 is wrong, as it says nullity to be 0. Now option 4 and option 5, if we check first, there are infinite number of ways to balance the chemical equation. There is a unique ways to balance the chemical equation. So to balance this chemical equation, we need the values of x1, x2, x3, and x4. But as we have already checked that we have one independent variable, that is x4. So that means there are infinite ways to balance this chemical equation, not a unique way. So that's why option 5 is incorrect, while option 4 is correct. Now left with option 3, we check that whether this vector is a basis for null space or not. So there are two ways from which we can check. The first way is if the vector 1311 is a basis for null space of the matrix A, and that means A times this vector should result in 0. Or other method is we try to find the basis for the null space of the matrix. We will look at both the method. So first let's try with this. For matrix A is 2, 0, minus 1, 0, 2, 0, 0, minus 1, 0, 2, minus 2, minus 1 times this vector. So if we try calculating it, so it is 1, 1, 3, and that is not equal to 0, 0, 0. So that means this vector does not belong to the null space of the matrix A. And if we try finding the basis for the null space, so for that we need the reduced row echelon form for the matrix A, and that was 1, 0, 0, negative 1, 2, 0, 2, negative 3 by 3, 0, 0, 1, negative. So from that, if we look at the last row, we will get x3 equal to x4. From second row, we get x2 equal to 3 by 2 x4. And from the first, we get x1 equal to 1 by 2 x4. So treat x4 equal to t, then the null space for matrix A would be we have some x1, x2, x3, and x4 such that, and for null space matrix is x, x1, x2, x3, and x4, okay, such that x is equal to 0. So let's treat x4 equal to t. So in that case, our null space would be 1 by 2t, comma 3 by 2t, comma 2, such that t belongs to some real number. So this would be our null space for the matrix A. Here our x2 is equal to 3 and x4 is equal to 1. So that means on putting t equal to 1, and we get 1 by 2, 3 by 2, 1, and 1. So this would serve as a basis for our null space, not our this vector. Hence option 3 is wrong. Thank you.